Good morning and welcome to this lecture of simple harmonic motion. We will try to cover simple harmonic motion in one or two classes. So be very quick. There is nothing very different from what we have done. Why we are doing simple harmonic motion now? Because we have already done with wave and wave equation. Do we remember wave and wave equation? The wave and wave equation was like this: y is equal to a sine omega t. Do we remember this? A standing for the amplitude, omega standing for the angular frequency, and t standing for time. Do we get this?
Yes, sir.
Okay. So this is also the equation of a simple harmonic motion. What does y stand for here? What does y stand for here? What will y stand for here? The same as what we have done previously. Y stands for the displacement of the particle. What does A stand for? A stands for the amplitude of motion. What does omega stand for? It stands for angular frequency. And what does T stand for? T stands for the time. Do we understand this?
Yes, sir.
So this is simply simple harmonic motion. This is just an overview of simple harmonic motion. I will try to tell you this in more details. And this is the sheet that I have already sent it to you, and we will go through this sheet very quickly. So what are the terms that come in simple harmonic motion? The first term that comes in simple harmonic motion is what is periodic motion. Periodic motion is very simple. Whatever motion repeats itself after regular intervals of time, beat your clock, beat the rising or setting of sun, is the rotation of earth or revolution of earth around the sun. All these motion, they repeat themselves after a fixed interval of time. Do we understand this?
Yes, sir.
Those motions are known as periodic motion. Motion of planet around the sun, motion of pendulum clock, motion of the hands or hands of the clock. All these motions are periodic motions. Do we understand this? Just take a note of this. I'll give you a minute. You have understood the meaning of periodic motion, then you can understand what is oscillatory motion. Oscillatory motion is very simple. In oscillatory motion, what happens? A particle moves about a point. It moves about a fixed point. Do we understand this? For example, if this is point O and a particle is moving like this, it goes from A to B, then B to A, then A to B, then B to A. This motion is known as
Oscillatory.
this motion is known as oscillatory or vibratory motion. This point O, what is the name of this point O? This point O is known as the mean position or equilibrium position. This point O is known as mean position or equilibrium position. With equilibrium, we understand why it is known as equilibrium position, because the force acting on this particle is zero. Do we understand this?
Yes, sir.
So, this is about oscillatory motion. Then what are these points A and B known as? This point A and B are known as extreme positions. Do we understand this?
Yes, sir.
Well done. Then what is the distance from O to A known as? This is known as the amplitude of motion. I'm using A here, I'm using A here, but this A is the name of the point and the other A is the amplitude of motion. Do we understand this? Can I have some raised hand that we understand this?
Yes, sir. Hand raised.
It's a very simple thing, beta, and very simple questions will come from this topic. That's why we are doing this right now. So what we have understood up till now is oscillatory motion, to and fro motion. People also call it to and motion. It vibrates back and forth, to and fro. Fixed point is known as mean position, and the other 2 points between which it is moving is known as extreme position. The distance of the extreme position from the mean position is known as the amplitude. Mean position is also known as equilibrium position because the force acting on the particle is zero. I'll give you a minute to note it down.
Okay, sir.
Okay, then I will try to make you understand from one simple diagram what I mean to understand. What is this point O is known as?
Mean position.
Mean or equilibrium position. Why it is known as mean or equilibrium position? Because the force acting on the particle here is zero. Do we understand this?
Yes, sir.
The acceleration is also zero and the velocity here is maximum. Can you remember this?
Yes, sir.
Force is zero, F is equal to ma, therefore acceleration is zero, but the velocity is maximum. This point is known as what? This point is known as extreme position. Force here is maximum for SHM. Acceleration here is maximum, but the velocity here is zero. Distance from here to here is known as amplitude. Can you remember this? Amplitude is written by the letter A, capital A. Do we understand this?
Yes, sir.
Now, when you displace the particle from the mean position, let us say the particle is here. Let us say the particle is here. What happens is whenever you displace the particle from the mean position, a force starts to act on the particle which tries to bring the particle back to its mean position. So if the particle is on the left hand side, force will act on the right hand side. If the particle is on the right hand side, the force will start acting on the left hand side. This force, which is trying to bring the particle back to its original position, is known as restoring force. Do we understand this?
Yes, sir.
What is restoring force, if I may ask? Whenever the particle is moved from its mean position, a force will try to bring the particle back to its mean position. This force is known as restoring force. Do we understand this?
Yes, sir.
Please note it down. I'll give you a minute. Then we will write the heading of SHM and try to understand when the motion is SHM. When I say simple harmonic motion, a simple harmonic motion is a periodic motion, so it will repeat itself after a fixed interval of time. That interval of time is known as time period. Do we remember this word, time period, capital T?
Yes, sir.
The simple harmonic motion is also oscillatory or vibratory. It is also oscillatory. So it has both types of motion inside it. It is oscillatory as well as it is periodic. If you have a spring attached to a mass and the mass is displaced, it will start moving like this. This motion is simple harmonic. If you have a pendulum and it moves like this motion is also simple harmonic. There is one more condition that you must remember. So we will read those conditions in the sheet. Right now, what you write is simple harmonic motion is periodic, it is vibration, it is oscillatory as well. Two types of SHM are there. Linear SHM, when the particle is moving to and fro in a straight line, that is linear SHM. If it is moving angularly, then the motion is known as angular SHM. The motion of pendulum is angular SHM, whereas the motion of this spring wala block is linear SHM. Do we understand this?
Yes, sir.
Please note it down. I'll give you a minute to do it. Then we must write what are the necessary conditions for executing SHM. The first condition is the motion must be oscillatory. The second condition is mechanical energy should be conserved. That means friction should be absent. Do we understand this?
Yes, sir.
If friction is present, mechanical energy will not be conserved, and we would want friction to be absent, or work done by friction should be equal to zero. If these conditions are failed, if friction is there but work done by friction is zero, then also you can have simple harmonic motion. Extreme position should be fixed, so it should not keep on moving. And the most important condition, the restoring force. Do you understand restoring force? Whenever I move the particle away from the mean position, a force starts to act. If this restoring force is directly proportional to the displacement of the particle from the mean position, displacement of the particle from the mean position, and it is directed towards the mean position, therefore the negative sign. Do you understand the meaning of the negative sign? So if the mean position is O, extreme position is A, and the particle is somewhere here, so what should happen here is a restoring force should act on the particle, and it should be directed towards the mean position, and this restoring force must be proportional to the displacement. X is the displacement of the particle. Do we understand this?
Yes, sir.
Why minus sign is put here? Because displacement is in the right direction, but force is in the left direction. Do we see this?
Yes, sir.
If the particle is here, then force will be acting in this direction, but as you can see, the displacement is in this direction. So displacement is in the left, but force is in the right. If this condition is met, if force is directly proportional to minus of x, or acceleration is directly proportional to minus of x, then this motion becomes simple harmonic linear motion. Do we understand this? Do we understand this?
Yes, sir.
Or I can write this force will be equal to minus kx, where x is the displacement of the particle from the mean position, and this k is known as force constant. Do we understand this? Have you heard the term k in spring constant? This k is same as the spring constant. In SHM, we call it force constant. Do we understand this?
Yes, sir.
We can write the acceleration as f by m, so it becomes minus k by m times x. So this becomes the equation of simple harmonic motion. Negative sign indicates that direction of force and acceleration is towards the equilibrium position. Y is the displacement of the particle from the mean, x is the displacement of particle from the mean position. Do we understand this? What all things we have seen here? What are the necessary conditions for executing SHM? It should be oscillatory, friction should be absent, energy should be conserved, extreme position should be defined, and force must be directly proportional to negative of the displacement. Please note it down. I'll give you a minute. We'll move ahead and we will see condition for angular SHM. In linear SHM, force was directly proportional to displacement. In angular SHM, torque is directly proportional to negative of angular displacement. Here, theta is the angular displacement. Do we understand this? In linear SHM, this force was known as restoring force. Here, this torque is known as restoring torque. Do we understand this?
Yes, sir.
So I can write this torque as minus c times theta, where c is known as the torque constant or the torsional constant. Do we understand this? There it was k, force constant. Here it is torsional constant. Do we understand this?
Yes, sir.
Here, there it was acceleration. Acceleration is directly proportional to minus x. Here it is angular acceleration is directly proportional to minus theta, where theta is the angular displacement. Minus sign indicates that it is towards the equilibrium position. So I can write it as minus c by I into theta. C is the torsional constant. And what is this I? This is moment of inertia. Do we remember moment of inertia? Mr square, ml square. Do we remember this?
Yes, sir.
Note this down. You might not have any question on angular SHM. You will have questions only on linear SHM, and that too very simple. We will try to cover them. I'll give you a minute. Then again, we move on, and I will ask you to make this table between linear SHM and angular SHM. Everything will be tabulated here. For linear SHM, F is directly proportional to minus X. Here, torque is directly proportional to minus theta. F is equal to minus kx. Here, torque is equal to minus c theta. K is known as the restoring force constant. You can call it restoring torque constant. Acceleration becomes minus k by mx. Here, alpha becomes minus c by theta. Minus c by I theta. Remember, this is how the equation of SHM is written in linear SHM. This is known as the differential equation of linear SHM. Many questions have come directly on this. Please note it down very carefully. Similar equation, you replace x by theta, c by k, and I by m. It becomes the differential equation of angular SHM. Remember, very simple questions will come on this chapter, and that is why we are doing this. At least one questions will come. At least one question will come, and even if a question of wave come, it is similar to SHM. It is similar to wave optics, and that is why we are doing it here. I'll give you a minute to note all these things down. Please remember the differential equation. Please remember the differential equation of waves of SHM. I'll give you a minute. Well, then we come to the next part where we see the equation of SHM. X is equal to a sine omega t. Remember the meaning of the terms. X is the displacement of particles from the mean position. A is the displacement, t is the time, and omega is the angular frequency. Do we remember this?
Yes, sir.
In case of angular SHM, we can write theta. Theta is the angular displacement is equal to theta naught. Theta naught becomes angular amplitude. Do we understand the meaning of angular amplitude? It is the maximum displacement in terms of angle on the other side. Do we understand this?
Yes, sir.
Omega is the angular frequency and t is the time. Acceleration here will be given by minus omega square x. Alpha will be given as minus omega square theta. This omega is the angular frequency, and this angular acceleration is also equal to minus k by m into x. From both these equations, we can understand that the value of omega square angular frequency is k by m, or omega becomes root over k by m. Omega is 2 pi by t. We already know it, or it is equal to 2 pi into n or f, where f is known as the frequency. We remember this equation. Omega is 2 pi by t is equal to 2 pi f, where f is the frequency. Do we remember this?
Yes, sir.
Same thing has come here. Here on this side, omega square is c by I. So omega becomes root over c by I. This is again equal to 2 pi by t. T is the time period, and that is equal to 2 pi into f, where f is the frequency. You multiply 2 pi by frequency, you get angular frequency. So everything now comes together, and we understand what is frequency, what is angular frequency, what is time period, what is omega square, what is k, what is m, what is c, what is I, what is alpha, what is k, what is torque, what is force. Can I have raised hands from all of you that we have understood what I'm doing here now? Everyone in the class, please raise hands. Great. I'll give you a minute to note it down. We have seen the formula for omega. If I do 2 pi by omega, we get the formula for time period. So remember, this is the formula for time period. Time period is 2 pi root over m by k in case of linear SHM. In case of angular SHM, it becomes 2 pi root over I by c. M is replaced by I, k is replaced by c. If I talk about frequency, frequency is omega divided by 2 pi. So I divide 2 pi with omega, and I get the value of angular frequency. So these are the only three formulas that you must remember, and I will show all the three formulas together. And here you can see on your screen all the three formula together: the formula of omega, the formula of t, and the formula for f. If you remember any one of these, and the simplest one is to remember omega, you should be able to find out the formula for the rest too. Do we understand this? Yes or no? No or yes?
Yes, sir.
Please note it down. I'll give you a minute to do it. Are we done, bacha?
Yes, sir.
Yes, sir. Then, sir. Here comes the next thing, sir. And the next thing is time period. What do you mean by time period? Time period is the time after which the particle keeps on continuing or repeating its motion. Time period T is 2 pi by omega is 1 by f. You all know this, yes or no?
Yes, sir.
Please note it down. Okay then. Now we try to understand the meaning of one oscillation or one revolution or one vibration. Yes, beta, you're audible. As you can see here, on this point, the particle is on this line. This is the mean position. Then it keeps on going away. It reaches the extreme position on the first hand side. So if I start from here, it will go to the extreme right. Then it will come down to the mean position. It will pass the mean position. It will go back to the extreme left. And then it will come back to the mean position. From mean position to mean position, one times left, one times right. This is known as one oscillation. The time taken to cover this oscillation is known as the time period. Do we understand this? And as you can see, this is a sine wave, and normally the SHM is given in terms of either sine wave or cos wave. Sine wave starts from 0, cos wave starts from 1. We all know this, yes or no? Please draw this diagram to understand what do you mean by one oscillation. We move ahead and we write the definition of frequency. Frequency is the number of oscillation in 1 second. F is equal to 1 by t, or F is equal to omega by 2 pi. The SI unit is hertz. It is 1 cycle per second, 1 revolution per second, 1 oscillation per second. Dimension of frequency are M0, L0, T minus 1. We all know this. Just note it down in a minute. Okay. I've already told you what do you mean by the term phase in wave wala chapter. Whatever comes inside the sine or cosine, this entire thing, omega t plus phi, is known as the phase or the phase angle. Do we remember this?
Yes, sir.
It basically tells us as a function of time where the particle is. Where the particle is at t is equal to 0. If I put t is equal to 0, the position of the particle becomes y is equal to a sine phi. Do we understand this?
Yes, sir.
At t is equal to 0, whatever is the phase of the particle is known as initial phase. Here, as you can see, the initial phase of the particle is phi. That means at time t is equal to 0, the phase angle of the particle is phi. This is known as initial phase or EPO. So if the equation of the particle is omega t plus phi, phi will become the initial phase. Do we understand this?
Yes, sir.
We have also seen part difference and phase difference. If we have two different SHM, one SHM is, let us say, this one, the other SHM is, let us see, this one. We find the difference in angle, and that difference in angle is known as the phase difference. Do we remember it? One of the waves is leading, which is a positive wave. It is leading, and the other wave is lagging. Do we remember this?
Yes, sir.
That is all that is explained here. What is phase? Whatever angle comes inside sine or cosine, that is known as the phase. At time t is equal to 0, the value of phase is known as initial phase or EPO. The difference of the angle between the two particles with respect to each other is known as phase difference. We have also seen the relation between phase difference, part difference, and time difference. Do we remember this?
Yes, sir.
I'll give you a minute to note this down. Anyone has any doubt, please raise up. We have already done this many times in the wave wala chapter, wave optics wala chapter. It's a repetition of what we have done. And again, it will be repeated in the chapter on wave motion. So everything will keep on going again and again. Do we understand this? I'll give you a minute to note it down. Well, we have seen the meaning of phase difference. Now, if you have two waves or two particles executing SHM, one is having phase angle of omega t plus phi 1, the other one is having a phase angle of omega t plus phi 2. How do you find the phase difference between the two particles? Phase difference is omega t plus phi 2, which is the phase of particle 2, and we subtract the phase of the particle 1 from it. Phi 2 minus phi 1 is the answer that remains. So phi 2 minus phi 1 becomes the phase difference between the second wave, second particle, and the first particle. Do we understand this? I'll give you a minute to note this down. Do we understand this better? This is what we had written, and this is what we are showing it. Write it down fast.
Yes, sir.
Let me move ahead and again come back to what we have already done. We have already understood the meaning of angular frequency. Angular frequency is omega, and omega is 2 pi by t, or it is equal to 2 pi f. The formula for omega here in simple harmonic motion also becomes root over k by m, or it also becomes root over c by I. Do we remember this? Yes or no? Here x or y is the instantaneous displacement or the displacement of the particle at any given point. A is the amplitude of the particle. This entire thing is known as the phase of the particle. We have just discussed this. This phi is known as the initial phase. Do we remember this? So this is the entire equation of SHM and the meaning of all the terms being explained here. I'll give you a minute to note it down so that we can move ahead in life. Let us move on and understand displacement, velocity, and acceleration in somewhat more detail. Let us note down some important points and then we will jump on to some question and wind off today's class. The first thing that we have to understand here is what is displacement, velocity, and acceleration. The first thing is displacement. We have gone through the equation many times. X is equal to a sine omega t plus phi. Omega t plus phi here is known as the phase. Phi is known as the initial phase. X is the instantaneous displacement. A is the amplitude. Do we remember this? Now, many a time when you see the equation of SHM, it will be given as x is equal to a sine omega t. Phi will not be there. Or x is equal to a cos omega t. Remember the difference between the two equations. When it is in terms of x is equal to a sine omega t, the time is measured from the mean position. If I put t is equal to 0 here, I get x is equal to 0. That means this equation, x is equal to a sine omega t, very important thing, x is equal to a sine omega t. This equation is written from the mean position. Do we understand this? Please raise your hands. But if I use the blue equation, and if I write t is equal to 0 here, cos 0 is 1, so the value of x will be a. That means this equation is written from the extreme position. So this is the difference between the two equations. Blue wala equation x is equal to a cos omega t is written from the extreme position, whereas the red wala equation x is equal to a sine omega t is written from the mean position. Do we understand this?
Yes, sir.
The direction of displacement is always away from the mean position. The total length of path, when I say total length of path, this is your O, this is your extreme A, this is your extreme B. From O to A, it is 2A. It is A. From O to B, it is A. Total length of path becomes 2A. Total work done in one complete oscillation is 0, but the total path cover, it will go from O to B, B to A to O, that will complete its one revolution. O to B, B to O to A, and A to O. The total length of the path will be 4A. Do we understand this? Yes or no? No or yes?
Yes, sir.
Please note this down, and I'll give you a minute to do it. Everything explained in much detail. I have told you the same thing 3 or 4 times. I hope You will remember it now.
Yes, sir.
We are done with displacement, and the next thing that comes after displacement is velocity. It is the rate of change of position or displacement with respect to time. To get the velocity from x, we just need to differentiate the equation of x. Do we understand this? Yes or no? So we differentiate x is equal to a sine omega t, and the answer we get is x is equal to a omega cos omega t. I can write it like this: v is equal to v max cos omega t, where the value of v max, which is the maximum velocity, becomes a times omega. Do we understand this? What I have done, I have just differentiated the equation. Yes or no? No or yes?
Yes, sir.
Now, if the equation instead of sine, if the equation was cos, and that I will write here, if the equation was the blue equation, x is equal to a sine omega t, if I differentiate this blue equation, I will get minus a omega cos omega t, because the derivative, sorry, I've written it ulta. If this equation would have been, sorry, my mistake, x is equal to a cos omega t, the derivative would have been minus a omega sine omega t. Here also a omega will be equal to v max, but the derivative of cos becomes sine. So if the equation is equation number 2, this is the derivative. It becomes minus a. If the equation is equation number 1, the derivative becomes a omega cos omega t. In both this equation, v max, the maximum velocity, is a omega. Do we understand this? So this way, or x is equal to a, v is equal to a omega cos omega t. This is one way of writing the equation of velocity. Do we understand this? Can I have reason that we understand this? Here, remember the value of a omega can be written as v max. That is the maximum possible velocity. This is the first way of writing v. I'll give you a minute to note it down. We move ahead and we move on to the next way of writing velocity. We have already seen that we can write velocity is a omega cos omega t. This is velocity in terms of time. In this equation, equation number 2, I am writing velocity as a function of x, where x is the displacement, and this is the formula v is equal to plus or minus. So it can be in the forward direction, it can be in the reverse direction, plus or minus omega times root over a square minus x square. Very important formula. Both of these, do not forget any of these. Do we understand this? First formula number 1 is velocity in terms of time. Second formula is velocity in terms of x. Do we understand this? Yes or no?
Yes, sir.
We can write this second formula by squaring in the form of third formula. So the second and third formula are nothing but coming from the second formula itself. Then by doing some mathematics, I can write it in this form as well. So please remember form number 4, because in exam any form can come for you. Now this is x by a square plus v square by a square, omega square is 1. This is in the form of equation of an ellipse. You have not understood, you have not probably read this equation of ellipse, but ellipse is a type of geometrical figure, just like a circle or a line. Do we know what is an ellipse? Elliptical shape. An egg is almost of an elliptical shape. This is the shape of the ellipse. If I draw x on the x-axis and velocity on the y-axis, this is how the ellipse will look like. One side will be equal to a. This is known as the minor axis. Remember, this is the minor axis, and this is the major axis. This one is the major axis. And we have the equation of ellipse. Do we understand this? If a question comes, they might give you 3 or 4 different figures, and they would ask you which is the figure, which is the diagram representing v as a function of x. This is equation number 1. V in terms of t. This is equation number 2, V in terms of x. Equation number 3, written in the square form. Equation number 4, same equation but written in the form of ellipse. Do we understand this? I'll give you a minute to note everything down. Is everyone following me? Can I have some raise hand that everyone is following me? 1 minute to note it down. Now we move ahead and we just note a very important point. We have seen that this is the equation between x and v and x, and it is the equation of an ellipse. If the value of omega becomes 1, if the value of omega becomes 1, the equation becomes x square by a square plus v square by a square is equal to 1, or the equation simply becomes x square plus v square is equal to a square. If omega becomes 1, then the path or the diagram becomes circular. Do we understand this? Yes or no? The next point that you must note is the direction of velocity of the particle in SHM. It can be towards the mean position when it is moving towards the mean position. It can be away from the mean position as well when it is moving from the mean position. At the mean position, x is 0, velocity is maximum, the value is a omega. I've already told you. At the extreme position, the velocity of the particle is 0. It has to be 0, otherwise it will keep on going ahead. Do we understand this?
Yes, sir.
I'll give you a minute to note all these facts down. One fact I have kept on telling you over and over again so that you always remember it. A minute. Well then, we are done with displacement. We are done with velocity. The next thing is acceleration. It is rate of change of velocity. So this is formula number 1, dv by dt. Velocity is a omega cos omega t. We have already seen that. If I differentiate it once more, this becomes the formula for acceleration. And if you look closely, and I will highlight it, a sine omega t, is nothing but equal to x. And therefore, the third formula comes, acceleration is minus omega square x. And remember, this omega square is k by m. So I can write the fourth formula of acceleration. Acceleration is minus k by mx. Is everyone getting me? If you look at the graph between acceleration and x, it is a straight line graph with a negative slope. So the graph goes like this. As you can see, on the extreme position, the acceleration is maximum, and this maximum value is minus omega square a. And at the mean position, the value of acceleration is 0. Do we all understand this? Do we all see this? Can I have some raise hand from everyone? I'll give you a minute to note this down. Remember the graph of v versus x, graph of a versus x, very important graphs, can come anytime. And what I'm going to do is I'm going to take you back to the diagram that I had drawn. You have drawn the previous diagram, yes or no? Between omega and x, between x and a and x. I'll take you back to the diagram that I showed you in the very beginning. Can I switch to that screen now? You noted it down? I'll take you back to the diagram that I had shown you. Remember this diagram? Mean position I had written, f is equal to 0, a is equal to 0, velocity is max. Now I know the value of maximum velocity. It is a omega. Do we understand this? Raise hands will give me more confidence that we have understood this. Yes or no? Now, on the extreme position A, we had seen that acceleration is max. Now we know the value of maximum acceleration. That will be equal to omega square multiplied by x. The value of x is a here. So I write it as omega square a, or I can write it as k by m times a, where this a is the amplitude. Do we understand this? Can I have some raise hand that we understand this? Similarly, for maximum force, to get maximum force, you just multiply A with M. So the formula of maximum force becomes m omega squared A, or I can write it as K times A. Remember, this force is always directed towards the mean position. Acceleration is always directed towards the mean position, but velocity can be directed towards the mean position. If it is moving towards the mean position, it can also be directed away from the mean position if it is moving away from the mean position. Do we understand this? Can I have some reason that we understand this? I'll give you a minute to note down this information in your sheet. I'll be back after a minute. That takes me to the last part of this class, and we will discuss the diagram or the graph of displacement, velocity, and acceleration. X is equal to A sine omega t. That was the equation of displacement. This is the graph of x with t. In the form of x, the graph will be equal to x. The maximum value will happen at x is equal to plus or minus a. Do we understand this? Yes or no? Raise hand will give me more confidence that you understand this. Do you understand this? Yes or no? You will get this graph in the sheet, so you can draw it and mark it from the sheet. I will just explain it to you because we have already discussed this. The next graph will be the graph of velocity with time, and it is in the form of a cos graph. Do you understand this cos graph? Yes or no? In terms of x, it is plus or minus omega into root over a square minus a square. We have already discussed this equation. Yes or no? Tell me.
Yes, sir.
And the value of velocity will be plus or minus a, plus indicating that it may move in the same, it may move away from the displacement, it may move away from the mean position, or it can move towards the mean position as well. Do we understand this? Yes or no?
Yes, sir.
The next two graphs are similar to each other because acceleration and force, you multiply a with m, you get the graph of force. So both the graphs are same. The only thing is it is multiplied by m. X is equal to a is equal to minus omega square x, or you can write it as minus omega square a sine theta. Remember, acceleration is always directed towards which position is the acceleration directed? Whether it is acceleration or it is force, it is always directed towards the mean position. This is what you got to remember. You have to remember these four graphs and draw it from your sheet. I hope you will get your sheet today. Yes or no? Do we understand this? Can I have some raised hands? Well then, this brings us to an end of this class. In this class, we have understood what is SHM, what is periodic motion, what is oscillatory motion. We have seen the equation of SHM, x is equal to a sine omega t plus phi. Omega t plus phi is known as phase. Phi is known as initial phase. A is the amplitude. Omega is the angular frequency. We have seen the equation of velocity. V is equal to a omega cos omega t. A omega becomes maximum velocity. It happens at the mean position. At the mean position, force and acceleration are zero. Velocity can be directed away from the mean position or towards the mean position, but acceleration and force are always directed towards the mean position. Acceleration is minus omega square x or minus k by mx. K is known as the force constant. Do we all remember this? Yes or no in a short? Well, we'll continue with the next class. We'll continue and try to wind up SHM in the next class. Meanwhile, you will get your sheet, go through the entire lecture. The lecture is also recorded. You can also see that. Take care, and I'll see you tomorrow, and we will try to wind up the chapter tomorrow. God bless you, everyone. Take care.